Can anyone tell me what a rational expression was? Because we're going to deal with this all chapter. What's a rational expression? So think, rational means it's a fraction, but rational expression means it has to have these kind of values in there. This is where you can look at your notes like 12-1. Oh. Okay, Hayes? It has to have variables. Okay, numbers. And the numerator and denominator have to be special types of expressions. Wyatt, do you remember? Yeah, you can look back. I'm totally okay with you looking back at your notes. The numerator and denominator have to be polynomials. So does the whole expression have to be a polynomial? No, just the numerator and denominator, which is hopefully clarifying. 4/5 times 3/7. Okay. Are these two rational numbers? So can they be written as fractions? Yes, because they are fractions. So they're rational. How do you multiply these? How do you multiply these two rational numbers? You guys remember? Multiply. Okay, yeah, multiply across the top, across the bottom. And so what would I get here? 12/35. Okay, nothing to that one, I hope. Yeah, you could, what? Cross cancel? If you had common factors, yeah. That's what I'm saying. I think that's what I thought that's what you guys are trying to bring up, but if not, it's okay. 3m. 3 over m times k over 4. K over 4. These are algebraic expressions because they have variables. Good. Oh, so how do you deal with this one? This is way different from the last one. Oh, wait. Yeah, you just multiply across. All right. 3 times k, 3k. M times 4, 4m. By the way, always write the number, the coefficient first, then the variable. There's your expression. Okay. Now we're going to get to rational expressions where you have polynomials, numerator, and denominator. And that starts with example number 1. So can you guys remember this? I hope you guys already knew this, but if you didn't, remember it. Because example number 1, we get a whole different expression. Can somebody read for me the rational expressions being multiplied? Yes, Beth, go ahead.
For the numerator, you do 3x squared y, and the denominator is 2rs times numerator 24r squared s. Denominator 15x y squared.
Okay. We have two rational expressions being multiplied. Oh, man. So what do you do on these? You do the same thing you did on the others. You multiply across. But you guys probably should see that there are some common factors, right? So what are the common factors of my... And really, the book gives you two ways to do it. We're going to go through the simplest, straightforward way. I want to cancel out factors before I multiply. So can someone give me one pair of factors that are common, or that have common factors? Two numbers that have a common factor. Walker, give me a pair. 2 and 24. 2 goes into 2 once, 2 goes into 24 12 times. Anything else? This is my favorite part. You're just making all these changes and make it easier. Yes, right? Go ahead.
Can you cancel like the variables?
Yes. The variables stand for a certain number. So you can cancel out those variables if they're common. Bless you. Yeah, give me another one, Benson.
R squared.
Yeah, how many R's are in R? 1. How many R's are in R? Or sorry, I should say R divided by R is 1. R squared divided by R is 1 R left, right? You get 1 R taken out of that. Okay. Anything else? Lisby? Yeah. S over S is just 1 over 1. Well, I'm going to start calling people because I think you guys can see it. Ellie, anything else?
3 and 15.
Yeah, 3 goes into 3 once, 3 goes into 15 5 times. Anything else? Kyra?
The
Yeah, you have 2 x's here and 1 x there, so you can cancel out one of them. Anything else? Man, this is like, have a field day with these right here. Josh?
Y.
Yep, you have 1 y there, you have 2 y's there. Anything else? We good? Okay, here's the fun part. What's 1 times x times 1 times 12 times r? 12. You can say rx or xr. Either one's good. What's 1 times 1 times 1 times 5 times 1 times y?
5y.
Are there any other common factors? Because what happens if there were common factors? You can cancel them out, but there aren't any. This is your simplified version. So this was the funny thing in 7th grade when we went over again multiplying fractions with just numbers. I would say, all right, cancel out common factors, and some people would do it. They're like, yep, I can cancel those out, get 1 and 5. And some people would be like, nope, not going to do it. I'm just going to multiply across. I'm like, fine. They could do it that way. You would get 72 over 30, and you can simplify that to 12/5. But isn't it a lot easier to multiply smaller numbers than it is the bigger numbers? And then you have to simplify even that. So you're doing all this process, and now hopefully you're all on the same page. Simplify before you multiply. Okay. Here's where we're going to have the review of yesterday's lesson, because I think you guys get this. And actually, let me give you a problem just to make sure you guys are fully getting it. On page 669, number 4. Let's just do number 4. Look at the instructions, though. You see what it says there? Find each product. We get that. Assume that no denominator has. So they're saying there are no excluded, like we don't have to worry about excluded values because we're assuming the denominator will not equal 0 on either one of those fractions. All right. So number 4, please. So I was, as you guys are working on it, I'm pretty pumped up today because today I have a little webinar I'm going to look at, and it's about how to interact with the board. And you guys, I told you about this before yet? Maybe I did. But how I can have your like Chromebooks hooked up to the screen. And it's from what I saw, it's pretty cool. Like I can pull up and say, James, all right, what do you have? And I click, boom, James's work is up here. Or I can say, all right, I need that group to show me what they did. All 4 of them that can show up there. I think we have to purchase something, but I have to get approval with that. And I have good support from the administration, so that's cool. That'd be really cool. So what I would do instead of that is I just come physically and come check all of your work, and then I can hold your paper up or make you explain it. But it's so much easier to go quicker, and you can interact with your Chromebook touchscreen.
You all have Chromebooks the whole time?
In that lesson or whatever, or in that part, yeah.
Plug my paper up to the screen.
Yeah. Or hold your paper up right here. Can you see that? Can you see that back there? No, you can't really do that. But on that, with that program, you can. Yeah. The other projector, yes. Which I like, but still has limitations.
Something we're not supposed to be on, you're going to expose us.
Well, yeah, it's actually going to tell me if you're idle from the program, so sorry. Sorry, guys. Thank you, Swivl, and the support team from Swivl. Okay, who has number 4, the simplified version? Raise your hand if you have an answer. Like you have something now. Raise your hand. Don't be shy. So if you're not raising your hand, that means you did not get an answer. There we go. Okay. All right. I'm going to go with Lisby. What'd you get for number 4? 12m over 5. That's it. How many of you got that? 12m over 5. Good. That's the answer. All right. Let's move on to the second. I guess I didn't even have to write this. The second example. example, and this is where we're going to get that review that I've been anticipating. We're going to do A. Taylor, can you read A for me on example 2?
Find each product.
Mm-hmm. A on number 2.
M plus 3 over 5M.
Just 5M? No. Okay, go ahead.
20m squared over m squared plus 8m plus 13.
Okay, is that written correctly? 15. Thank you. Okay, is that all good? Okay. The first thing we want to do before we start multiplying across is to look for those common factors, but I don't even see factors here. So I want to make everything factored out as much as I can. Can I factor out m plus 3 anymore? Can I factor out 5m anymore?
Yes.
You can just say 5 times m. So we're going to leave it like that. Can you factor out 20m squared anymore? Nope. Can I factor out m squared plus 8m plus 15? This I can do. So what would it factor out again? It's going to be that simple form. There's a 1 here. You're going to get m and m. So what is it? Plus 3 and plus 5, because positive 3 times positive 5 is positive 15. 3 plus 5 is 8. That is it. So I'm going to cross this out, not because it's just eliminated, but I rewrote it in factored form. Okay, everything's factored. Are there any common factors in numerator denominator? This is review, right? Because we did this yesterday. Yes, ma'am. M plus 3 will cancel out right here, right there. Numerator denominator. Anything else? M. This m and this m, you're going to be left with m over 1. Anything else? Hayes? 5 and 20. 5 goes into 5 once. 5 goes into 20 4 times. Anything else? Okay, and really I should have put here m plus 3 over m plus 3 is 1 over 1. Okay, what's 1 times 4 times m? 4m. What's 1 times 1 times 1 times m plus 5? M plus 5. Is there anything else left to cancel? What about those m's, Beth?
The bottom one is in addend.
Good. And one thing I want to kind of emphasize in the lower grades, and we're doing a lot of good things at the school. I think we're trying to talk with the teachers in math who teach math throughout the years. And one of the things I really want to emphasize is the terms you use in math, right? Like, how many of you know what an addend is? Does anyone remember when you first were exposed to the word addend? How old were you? What grade you were in?
4, maybe. I think it was 4. Probably.
So maybe first grade. A lot of you are saying 4, third. It should have been given to you as soon as you learned addition. So when you were doing this plus that, those two numbers were addends. And if you get that down, then this is very comfortable. These are addends. Yeah, I've known that for 5 years, 6 years, whatever. So we got to emphasize some of these words because the words mean a lot. These are factors, right? You're like, factors? They're being multiplied, right? Are these factors? So you can't cancel out a factor with an addend. That doesn't work that way. So they got to match up. Sorry? And how about this? Let me clarify. Are these factors of each other? These two?
No.
Are these factors of each other?
Yes.
So maybe that'll clarify. Yes. Because you're thinking of all those ones and all that. Okay, that's good. Can someone read for me B? Benton, read B for me on that example 2.
Numerator 3, parentheses, x plus 5. And then, you can go on. And then 4 times, and then in parentheses, 2x squared. Plus 11x plus 12. And then parentheses.
And then times.
Times 2x.
And they were kind of like this. Okay, so you're multiplying these two together, and you're like, what do I even do? Well, first of all, you're multiplying two rational expressions Does this second rational expression have a denominator? What is it? It's 1. So if you really need to see that, that's okay. You can write over 1. Okay. Has everything been factored? No. The top of the first, or I should say the numerator of the first fraction, yes. The denominator of the first fraction, no. So is there a common factor in here? In the trinomial here? No. So do you guys remember how to do this one?
2 times 12.
You're going to do your 2 times 12 here. And I think you guys can get a little bit quicker on this, but it takes practice. So 2 factors of 24 that add up to be 11.
8 and 3.
Okay, I'm going to check 8 and 3. So what's 8 times 3? 24, excuse me. What's 8 plus 3?
11.
So that's it. Do you know what you do with those numbers?
8x plus 3.
Yeah, so I'm going to take this. I'm going to get 2x squared. And then I'm going to put plus 8x plus 3x. And then you do what? Your grouping. Yep. Get your factor by grouping. Let's see what you guys get. Is this from chapter 10?
Yeah.
Yes, unfortunately for some. But it's good practice because you're still doing the same thing. Wait till Algebra 2, guys. You'll get some nice news on this stuff.
What is that? Wait a minute.
That's a cliffhanger of a year. A year plus. A year and a half, maybe. Just mark my words. This gets better. Okay. Common factor here is 2x. You're left with x plus 4. Here's the factor 3. You're left with x plus 4. So what does 2x squared plus 11x plus 12 factor down into?
2x plus 3.
So this is what I'm going to do here. Either you can rewrite it or you can just erase. So you get here 4 times x plus 4 times 2x plus 3. You guys agree with that? Okay. And this is a good hint. Not always, but this is a good hint. If you factor this, you usually have one or both factors that have another common factor in the numerator or denominator, depending on where it was. All right. Anything else left to factor? No. So anything cancel out here? Yes, sir? 2x plus 3, 2x plus 3. Anything else? No, and I need to make sure here. Okay. We're going to write it. We're going to leave 3 times x plus 5, 4 times x plus 4. And is there anything else left to cancel here? No. So your answer is going to be 3x plus 15. You distribute. You distribute here. And then what's 4 times x plus 4? 4x plus 16. Anything to cancel? Oh yeah, there is a GCF. Right here and here. But you're done. There was nothing left to cancel, so you're done. You can leave it like that. No, I think there's a question there. Go ahead. Yeah, these are being multiplied. These are being multiplied. What's prohibiting them from being factored out? Because I get it, but they're kind of a combination of addition here, addition there, so don't cancel them out. Leave them alone. Could you see it here that they could not be canceled out? Do you guys see here they should not be canceled out? So then here they shouldn't be canceled out either. So that might help you. Yes, sir?
Oh, wait, never mind.
Okay. How about trying out number 6? Ask yourself, did it get factored out? If so, then you can start canceling out and leave what's... Yes, go ahead.
What does it matter if you leave the 3 and 4 out because like you factored them out?
Let me check something here. I'm okay with you leaving it. That's a good question. And this is where the book gets picky. You can leave it like this or like that. Yeah. I'm okay with either one. Done. Oh, my. Okay, number 6. We're going to go through this as a class once you're done working with it. Okay, looking at number 6. Vivian, could you have factored out number 6, the way it's written? Can you have factored that out anymore? So when I mean, could you have broken any of those? No, so you're done with factoring. All right, can I cancel common factors? Katie, are there any common factors? Yeah, you cancel out the x minus 5 and the x minus 5. Good. Anything else to cancel? Riley? Yeah, the r in the denominator cancels out with the r squared, so you're left with 1r at the very top. Okay, what's your final answer, the simplified version of number 6? Okay, Wyatt?
R over y plus 3.
Good, r over y plus 3. How many of you got that? Okay, good. All right. I'm going to go through one other type of problem, and then that'll be the lesson. This is what I was thinking before Monday when I start writing my lessons. I was like, lesson -2 and -3 are almost the same. You know what -3 is about? You can look at it. Dividing rational expressions. And do you guys know how we do dividing fractions? Stay, change, flip. You do the same exact thing with these. You do stay, then change, then you flip it. That's it. Just work it out the same way.
Let's just get through.
Can we just like
Do 3.
since we already know how to do it?
So what I'm going to do, because of the way time is going, we're just going to have this lesson today. Make sure we nail this down. If you have questions on -1, you can get that today. And then -3 shouldn't be hard. We'll get that tomorrow. Which is Wednesday, which is nice. You get less homework.
Look at that organ
Look at that organ. Okay, yes. Look at that duck. Okay. Let's look at example number 3. Do you see what it says on example number 3? Refer to the application at the beginning of the lesson. I thought this was an interesting problem with traffic jams, and some of you are maybe not there yet, but you're going to get to where you're going to get your permit, get your license. You're going to experience some of these possibly. Not as much in Greenville, but we do get some of that. I'm reading 667. On the Sunday after a recent Thanksgiving, westbound traffic was backed up for 13 miles at one exit of the Massachusetts Turnpike. Assume that each vehicle occupied an average of 30 feet of space in a lane, and that the turnpike has 3 lanes. You can use the expression below to estimate the number of vehicles involved in the backup. Don't turn to the answer, because I want us to find this out, and we can do it pretty quickly. Can someone read to me that expression where it says 3 lanes times? Benson.
3 lanes times 13 miles
Over 1 lane? Okay, and yeah, we can say 1 lane.
Okay, and then 5,280 feet over a mile.
5,280 feet in 1 mile.
And then 1 vehicle over 30 feet.
1 vehicle over 30 feet?
Yes.
Okay. You're looking at this problem thinking, oh my goodness. Okay, first of all, is it multiplication?
Yes.
Yes, okay. It's just a long string of multiplication. They are rational expressions. They have the units. All that stuff looks really confusing. I'm going to help you out right now. The most fun I have with multiplying. Okay, come back to me. So I'm guessing this lesson will not be the one I post. Bummer. Okay, but anyway, just like I did with the other problems, can I put 3 lanes over 1? Okay. Now I'm going to have the most fun right now canceling things out. Can't I cancel out common factors? I can cancel out units in the same way. Units can be canceled out. Units. The lanes can be canceled out.
Okay, I don't think that works.
It does work. Watch what happens. This is cool. Is there anything else I can cancel out? Just watch it. I don't expect you to fully understand it yet. But can you cancel out anything else? What are you left with? What was the problem asking you for? How many vehicles? So do I have any other unit but vehicle? That's what I wanted. That's good.
No, you can wait. 30 and 3.
Okay, let's start looking at this. The 3 can cancel out with this 30. So we got your 10 and your 1. Do you guys agree with that? The 3 up here and the 30. Anything else can cancel?
Yes.
Yeah, the 10 and this becomes 52 or 528. Here's the fun part. You start off with this problem. You're multiplying this times this times this times this times this, and you end up with this. 1 times 13 times 528 times 1. Really, 528 times 13 is your problem. 24, 6, 8, 15, 0, 8, 2, 5, 4, 16, 8, 7. Oh, no, 6. There's an imaginary number. Okay, and we're estimating, so we didn't have to get the exact answer. But what units are left up there? Units. Vehicles. And what's 1 times 1 times 1 times 1? So what's my answer?
6,864 vehicles. Wow.
You did that. This process right here, they call it your book calls it dimensional. This is really cool. Ready? It's really out there. Dimensional analysis. Okay. What you're doing is all you're doing is looking at dimensions like lanes, miles, feet, vehicles, and you're realizing that you can cancel things out just like that. Can I give you another one that's maybe more practical, like more understandable? You'll be like, okay, I get it. Oh, by the way, about 7,000 vehicles were backed up at that time. Is that a lot? That's a lot. Okay. For New York. I think even for New York that might be a little tough. But yeah, definitely for Massachusetts. And
Oh, no.
we'll do it. We'll do it at the beginning of next hour. We'll do another one, and it'll be cool because you do this all the time, or you could do it very quickly. Yes, ma'am.
I did my homework, but
Awesome.
I don't really understand it, so I'm not going to turn it in. So when you don't get in there, that's why.
Okay.
But after we did this for problems, I think I understand it more.
So you're maybe thinking what can cancel out? Is that what you're wondering, or what the excluded values are? Which one of those?
Kind of both, because I was either like equal 0.
So do it like we did in that last chapter. The denominator equals 0. Find what those variables will be. Yep, you'll get it. And we'll get more practice today and tomorrow and the next day.
Another day
Of what?
Kids basketball coaching. I
Oh.
think I would be a great coach.
Sorry?
I think I would be a
Oh my. Oh man. That sounds like a good plan. If you guys, as you're coming in, if you guys could take out that homework quickly, make sure your name is on top. Because if your name is not on top and it's turned in, it's a 0. Like I don't take it. I recycle it. Okay, if your name is on top, you can go ahead and just a little bit. We'll wait as everyone settles in. Pass it up, pass it down. I'm going to grade it myself. I'm going to make my life harder tonight by grading it myself. But I want to try something out this quarter. Hopefully it's helpful. We'll see. So pass up your homework. Just make sure your name is on it. Yes, if you have your test signed, bring it up here, face down. Bring your tests up to the podium face down if you have them signed. Get your homework out, put your name on the top, pass it up. Yeah, you're not going to grade it, I'm going to grade it. test up there. Yes, please. Wow. A lot of tests signed. Good thing here. Homework, you can give it to Carrie. Homework should be passed up. Make sure your name isn't on it. If your name is not on it, I can't take it. A lot of tests are signed, which is a good thing. Oh, even more. Pass up the homework, please. And I'm going to grade the homework myself tonight. More willing. Oh, it's like my birthday every time I get one of these back. Yeah, you can take it out, put your name. Yeah, I'm going to give them back, thankfully. Yeah, but try to do it on separate, because in case I didn't get it back, you still have your notes. Any other tests? Okay, your tests are due signed if you didn't already get them by tomorrow. And I'm gonna look down the list. Who has it? Great. You're good. You're set. But if you didn't have it turned in by tomorrow, I'll have to take some break time from you. Okay, what I want you to do is take out your notes. And you can do this at the bottom of yesterday's lesson. Take it out. And I want you to work out these 4 problems up here. And I'll tell you what to do on those in just a moment. Thank you. Let's go ahead and pray before we get started, and then I'll give you some more time. Father, we are grateful for today. We're thankful that we can review the lesson from yesterday and also get into another lesson. Help us, Father, as some things are not always clear at first, that through practice, through more explanation, through different scenarios, we can figure it out more and more easily. And then, Father, I pray that you help each student to do well, not only on this little warm-up, but also on the lesson itself. In Jesus' name we pray. Amen. Okay, if you guys can just close those 2 back doors, that would be nice. Thank you. And I'll give you about 5 minutes to work on those problems. I want the excluded values up there on the board. The excluded values, what the variables cannot be, and then simplify those expressions as best you can. Can you see them? Yeah, sorry, it's number 1, number 2, number 3, number 4.
On number 1 is y minus.
It's
on the bottom.
It's y minus 4 times y plus 4. Yeah, sorry. I know it's kind of hard for you guys. Can you all see them over there especially? Okay, ask a question if you can't see it. But these are on your own here. You can look at your notes, by the way. I don't mind you looking at notes. You can look at the book. I want excluded values and simplified versions of those. You have about 3 more minutes. can't help. I'm sorry. It's like a mini quiz, but it's not graded. Just can't help. Sorry. Okay, a little under a minute. And it's okay if you didn't get them done. You can still kind of work while we're doing the first ones. Okay, let's go through that first one. Can somebody give me the excluded values for y? So what can y not equal? I'll go with Matt. Do you have any?
Number 1.
Yes.
4 and -4.
4 and -4 is correct. And maybe you're wondering, how do you know? You look at the denominator, and all you have to do is set it to equal 0. That's all you have to do. When you set it to equal 0, what can y equal here? Or y minus 4 equals, you remember this process? So you add 4 to both sides. And then here you do the same thing. You subtract 4 from both sides. So y cannot be 4 and -4. Why can it not be 4 and -4? Does anyone know the reason behind it, Maggie?
Because you don't want it to equal 0.
Yeah, you don't want it to equal 0. So you figure out what it takes to equal 0, and then those are excluded. Claire?
Why can't you just cancel out the y plus 4 and y plus 5?
Yeah, you're going to do that to simplify, but I wanted excluded values too. So the next thing is, how do you make this simpler? How do you simplify it? And, oops, that's not what I wanted. Brian, did you get the simplified version?
Yes.
What'd you get?
I got 1 over y minus 4.
1 over y minus 4. Okay, but how'd you get that?
I cancel out the y plus 4 on the top and the y plus 4 on the bottom.
Yep, the y plus 4s can cancel each other out. You're left with 1 over y minus 4. How many of you got the excluded values for this number 1? How many of you got the simplified version for number 1? How many of you got both? Okay, so good. Most of us got that one. All right, second one. What are my excluded values? Jack, do you have anything? For n, what can n not be?
1.
1, he says. How in the world is that? Why can't it be 1?
4 minus 1. Or 4 minus 4 is 0.
Yeah, 4 times 1 would be your 4. Minus 4 is 0. You do not want that. How could you figure that out if you're like, I don't know how you figure that out. Just do 4n minus 4 equals 0. Then you solve for it and you'll get n equals 1. You don't want it to be 1. Yes, ma'am.
Wait, are you solving for the a on the bottom?
Always on the bottom. Yeah, don't do the top because I need to find out what can the denominator not have. In this case, n equaling 1. Okay, but now I want to simplify it. So who has a simplified version? Carson, do you have a simplified version?
N plus 2.
N plus 2. How'd you do it? What'd you do?
So I did the subtraction process. So the 4 minus 4 is 0.
You subtracted these?
Or simplified it to 1.
Gotcha. Okay, here's what you want to do on these problems, and this is for the next two, this one and the next one, sorry. What you want to do is factor it out completely. Factor it out completely. the numerator. Can you factor it out? Is there anything to factor out? Is there a GCF? 4. You're left with 4 times n squared minus 2. You guys agree with that? Okay? The denominator, what comes out of that? 4 again. You're left with n minus 1. Can you factor the numerator anymore? Isn't it a difference of? Is it a difference of squares? Okay, it's a difference. That's square rooted. You can do that. Can you square root 2? No, it's not a difference of squares. Can this be factored anymore? No, you can't make it. You can't break it down anymore. But yes, ma'am?
With the n cannot equal 1, wouldn't it be like negative 1?
Well, what's 4 times negative 1? Negative 4 minus 4 is negative 8. So it can be negative 1. Yep.
But when you do the solution, you get 1. When you
So if you were to factor this, like right here,
no, the n equals cannot equal
1. Yeah. I'll talk to you more about it if you need help. Yes.
So, can you only do GCF if both denominator and numerator have a common factor?
Yeah, and you have to check, can this be factored anymore? In this case, no. So are there any common factors that can cancel out? Anybody?
4.
So what are you left with? N squared minus 2 over n minus 1. Is that what you had, Carson? I'm sorry. Is that what you had right there? Okay, that's right. I didn't know if I heard you wrong or if you had that differently. I don't know. But that's what you should get on that one. How many of you got that? Simplified version. Okay, just a couple of you. That's all right. Questions? Yes, ma'am.
Wait, so like, I was thinking it was the kind where, like you subtract the exponents, like the one on top and the one on the bottom. So
You-
you're not doing that?
Well, you could do that if this and this were being multiplied. So are these two being multiplied? No, these two being multiplied? No, so you can't cancel out that way. We'll get more on that as well. Okay, on this one, I'm going to give you a little bit of time if you need it, if you did something differently. But what's my first step on these? Factor. Can I factor the numerator? Is that possible? Okay, is it a difference of squares? So this is the numerator. What can that be factored into? X, oh, that's not it. It's x minus 7, x plus 7. That's the difference of squares. The denominator, thankfully, has a 1 in front. So I can factor it out into x in the front, and then does anyone know what the two factors, or the two second numbers would be, Lucy?
Isn't it -7
Negative 7, positive 5. Well, let me check that. What's negative 7 times positive 5? Negative 35. What's negative 7 plus 5? Negative 2. That is it. Okay, here's how you can do these problems from here on out. My first step before I do anything, factor everything out as much as you can. So can I factor this anymore? Is there anything else to break it down into? No. Once you have it factored out completely, now you can get your excluded values. So what can x not be? 7 and negative 5. Those are the excluded values. Okay, you factored it out, and you can't have it be positive 7 or negative 5. So that's why I put that 0 there. Okay, so how do I get this simplified now? Turner, do you know what to do on this one?
Cancel out x minus 7 and x minus 7.
That's correct. And what are you left with? X plus 7 over x plus 5. Now, some of you are probably thinking, Mr. A, what about those x's? Can't they be canceled out?
No.
Why not? They're x's. They're right on top of each other.
Because there's technically a parenthesis, or
You'd say that.
they're like not the same equation.
Okay, here's the explanation, and I hope, and I was telling the other class this. Do you guys remember what grade you were in, or maybe how old you were when you first learned about addition? Do you guys remember that? Anybody? Can anyone kind of guess? The other class gave me some. First grade, some of you. Some said fourth grade. I was like, it might be a little late. I'm thinking like maybe a little bit of kindergarten, depending on where you were, who your teacher, all that. But at least by first, second grade at the most. Your seventh grade, you should have known addition. Okay. I hope, and this is where our school, we're doing something as well. We're like talking with all the math teachers, like all who teach math, and like, what are some things they need to know when they get to 8th grade, 7th grade, 6th grade, 5th grade? And one of the things that I think we need more of is the terms, the terminology. X and 7 are called addends. Do you remember that word? You should have learned it when you first learned addition. And so it should have been 5 years now, 6 years maybe, that you've had this, or no, I'm sorry, like 7, 8 years that you've had it. But let's just say these are addends. You guys okay with that? Are these two addends? Okay. Can you cancel an addend with division? What do you guys think? Are they inverse operations, addition and division? So can you cancel these two out? No, you're canceling two addends with division. Does that work? No. Only if these two were being multiplied and these two were being multiplied can you cancel out. Does that make sense? Because what undoes multiplication? What undoes multiplication? Division. There you go. It's early. I understand. Last one here. Can you factor out the numerator and denominator anymore? Can you factor it out anymore? The answer is no. It's already factored out. Excluded values, what can m not be? Anyone know what m cannot be, Abby? What can m not be in this problem?
1.
Positive 1. That's it. So all you have to do is set it to equal 0, solve for m, you get 1. Yes, ma'am?
Why can't you cancel out m minus 1?
You can, but that's after you find the excluded values. So first factor, find the excluded values, then simplify. So in that process. Now what can be canceled out? Yeah, m minus 1, m minus 1. And what are you left with here? M is the simplified version of that. Yes, sir?
I thought you said it's being multiplied.
Okay, so this is the question. This is being multiplied by m minus 1, you said, right? Are these factors of each other? Like this is a factor of that? They're factors. You remember what that is? That's that whole, when you learn multiplication, I'm thinking third, fourth. These are factors. So can factors be canceled by division? Yeah, because multiplication can be undone by division. So these can cancel out. Not if they're being added. If these two are being added, you cannot do it, but they're being multiplied. Again, we'll get more practice. Thankfully with 12-2. Okay. How many of you, did anyone get all the excluded values? Like all the excluded values on all 4 problems? Maybe not all the right answers for everything. All excluded values? Raise your hand. Okay, did anyone get all the simplified versions? Okay, did anyone get the simplified and excluded? Oh my. Okay, so the other class, it was similar. Not the exact same, but it was similar. You get more practice with 12-2. Aren't you thankful for that? Thankful? Or you're done with this lesson? Thankful. Good. Okay, let's go to 12-2 here. By the way, I want to give you a little word of encouragement and a little exhortation, plus a little bit of rebuke. You're starting to study for your test right now. Do you understand that? You're doing your test material right now. So don't come to me 2 days before the test or a day before the test and say, Mr. A, I don't get 12-1. How long has it been since 12-1? This test is going to be in 2.5 weeks. Do you want to start studying in 2.5 weeks, 12-1 again? No, please don't do that. IXL is your friend as well, as some of you have noticed. 12-2, we're talking about multiplying rational expressions. Okay, multiplying rational expressions.